Welcome to a little bit of lab rat fun networking with fish. Gonna go ahead and talk about an IWAN situation that I don't necessarily play with as much in the lab. A lot of times I'm doing proof of concepts. People will have multiple data centers, but in this data center, as you can see, what we're doing is we're taking the new IWAN boxes, IWAN termination boxes, and in a migration strategy leaving the legacy. There are actually two legacy CE boxes up here. This one is actually called Bud in the CPOC environment. This one cores again in the CPOC environment. There actually is one data center with two physical routers that connect in again as CEs to the MPLS provider to have circuit and router redundancy at the data center. And then what we're doing is the I-block model. So the traffic, so you can imagine that this box right here in the middle, which is behind the tunnel, which is where this physical interface is going into, and this physical interface is going into. This can be a WAN aggregation router or a collapsed WAN aggregation and core router. And then I actually have my traffic generation, which is right here in 10.101.100 /24, and then I have a traffic generator up here in 10.1 /16. And so what we're going to go ahead and do is we're going to have traffic go back and forth between these. I'm going to prefer the EF traffic or the business critical traffic to go over tunnel 10. Now what's actually going to happen is that I'm actually going to have two NHS. So next hop servers. NHS is a terminology based on RFC 2332, which was written in April of 1998 by Core Competence, Bay Networks, Juniper, and Cisco. So again, April of 1998. DMVPN is Jerry Tricks in a NHRP environment. So what we're going to actually do is Belgium is actually going to go ahead and have 3 NHS, 2 in this data center, 1 in the other data center. But since this data center, we're going to send an advertisement out saying, I can get you to 10.101, and this one's also going to say, I can get you to 10.101 via EIGRP or BGP in the IWAN model, where EIGRP or BGP would be the routing protocols you would run over tunnel 10. Then in our situation, we're doing EIGRP. And so what's going to be really cool is we're actually going to look and we're going to say, oh, we can get to either one. And so these paths are going to be very important. Remember, this is intelligent path control. So there's a path from me to here, and then I'll also be probing the other path, which is going to be kind of sort of cool. And then what we're going to do is run EF traffic. It's going to go across here. And then it's going to go ahead and we're going to do delay right here, which will impact both paths on the MPLS, and then we'll switch over to the INET path, because by impairing right here, we are impairing the underlying transport that both paths are over. So get off of the MPLS, get over to the INET tunnel. Now what we're going to go ahead and do, as I was mentioning, is just from a physical perspective, and I just want to show you this also, is that this is again a migration. So in theory, Bojangles would actually have gone up as a WAN termination as well as a DMVPN hub and PFR, Intelligent Path Control border. So in theory, normally Bojangles might go ahead and come up here in a fully migrated state. A lot of times people will want to not necessarily touch their legacy boxes up here while they're piloting or migrating some of the devices over. So again, this is called the I-block model. You can actually look up at Cisco Live in Berlin. There was a migration Cisco Live course. Again, remember, Cisco Live breakouts are completely free. Don't use your CCO password. Go ahead and make up a different password. I know they're completely free because I have some bogus Yahoo password I go ahead and check in with every now and again, so it's not my Cisco. You can watch VODs, you can download the PDFs. All of the breakouts are free for Cisco Live. The only thing that costs additional, the only thing that they don't have recorded on the Cisco Live is actually the technical seminars and the labs, which cost the attendees additional extra money. So What we're going to go ahead and do is what you'll notice is we're going to basically set up as a rail. So when Bojangles is doing a tunnel to Belgium, we're actually going to go ahead and specifically go over this physical path over Bud. And when Baby Bell is doing a tunnel to Belgium, they want to go ahead and go over this physical path. What that allows is that instead of saying I don't care which one I go over and then letting the WAN aggregation or collapsed WAN aggregation core switch right here do the ECMP and decide which way you're going, then you'll go ahead and just come into here and then we'll load share because the CSR 1000B will actually realize that it has two paths out here going to that environment. So let's go ahead and play. So let's go ahead and go into here. And what we're going to do is we're going to go ahead and I already have EF traffic that is going across here. So I have traffic with a Spirent traffic generator that's going between here and here. Okay, so now let's go ahead and go over to the traffic generator. I'm running traffic over here. So here's a Spirent traffic generator, and actually you can't really tell too well, but I'm actually running arrows. So I have EF traffic going from data center 1 to site 1. I have CS1 traffic going from data center 1 to site 1. I have EF traffic going from site 1 to data center 1, and CS1 traffic going from site 1 to data center 1. These have the little blue arrows over it, so these are the ones that are actually going right now. Each one is sending, so I'm sending 1, 2, 3, 4 streams. I'm sending 2 streams or 200 frames per second. Each stream is 100 frames per second. And I'm going again from the data center to the site and from the site to the data center. And I was actually playing before and caused some delays. You'll actually notice that I was actually playing. So you can see that before when I did a delay of 200 in my environment, and I think I said that we were going to do a delay of, how much did I say the delay was going to be? Yep, 200. Okay, so what we're going to go ahead and do is come back over here, and you'll see that I actually have reordered because I actually caused delay before of 200. You can actually see that there was a 300 here and a 300 here. Okay, maybe I did a delay of 300, but and it was only on the EF because it's only the EF that's actually going across the thing that I was delaying. So what I'm going to do is I'm going to do a clear counters. We're going to start from scratch. Now let's go ahead and I'm actually sending EF and CS1 traffic. And you know what? Let's stop the CS1 traffic. So let's stop the CS1 traffic. So we actually only see the EF traffic. So let's clear that. You'll see that this goes from 200 to 100. And so if we come back over here, so I'm only doing the EF traffic. So I have EF traffic going from site 1 to data center 1 and from data center 1 to site 1. Now, we had talked about the fact that what I thought we are going to be doing is we're actually going to be making sure that the tunnel that goes from Bojangles to Belgium only goes over Bud, and the tunnel between Baby Bell and Belgium only goes over cores. So let's go ahead and double check that as well. So let's go ahead and go into here. And I've got a filter up here, which is tunnel with Baby Bell. And what it is I'm actually using for tunnel with Baby Bell 192.168.1.2 is the MBMA address for Belgium. And this is the other side of the tunnel endpoint, which is over at Baby Bell. And so we've got Belgium and Baby Bell. And so if we actually do a refresh, again with Baby Bell, we're supposed to only have the tunnel actually go physically over cores, and that is exactly what you're seeing. And so let's go ahead and come over here and tunnel with Bojangles. And again, Bojangles should be railed and nailed up to only go across Bud. So that's what we have here. Now let's also go ahead and see what's going on with, let's go ahead and do a no display. Now when we do a no display, we're actually going to get everything. Now let's go ahead and let's not do everything. We don't want everything. What we want is flow IP equals 10.100.100. I'm sorry, 10.1.100.10. Now I could go ahead .100. I could go ahead and have used a filter over here. I'm just showing you a different way of doing it with live action. So what we actually see is we still see the legacy CS1 because while we stopped it, this is a NetFlow 9 collector on steroids, and it's telling us what's actually happening over a period of time. So it's actually telling us over a period of time what was and what is happening. So we still see the CS1. Once we actually refresh a little bit, we will see that the CS1 will go away, and there the CS1 went away. Now, the interesting thing is what we're actually doing is you can see that the traffic is coming in, it's going to Belgium, it actually is going out and choosing the path to Bojangles. Coincidentally, it's actually going back out from here to Bojangles and back out. So we should see that we're actually choosing as the primary channel, the channel that is going out path 0:1, because Bojangles is path 0:1 in an intelligent path control perspective, and Baby Bell is path ID 0:11. So let's go ahead and come back over to here, and we're going to go into the domain master controller. So what we're going to do is we're actually going to go into this domain master controller. Remember, the domain master controller in an IWAN environment is the brain that has the one policy to rule them all. So it has the one policy to rule them all, what's supposed to happen, where it's supposed to happen, and then it's supposed to let once the other masters at the other sites come in, we push the one policy to rule them all back down to it. Now what we're going to go ahead and do from this perspective is we're going to go ahead and realize that this domain master controller is also the master for this data center 1 WAN site, which means that it is the master in charge of the borders. I had one customer say that it helps him to remember that the borders take the orders. Now, where is a border? Well, congratulations. If you are a router that is on either end of a DMVPN tunnel, you are a border, and you will be defined as a border. That's where you'll be having the intelligent wide area decision-making line, as it were. So let's go ahead and fill this in. So from this perspective, the traffic should be coming up out of the data center, and we should be able to go over here and get the master view. So if we actually do a show master traffic class summary, we can see that our EF traffic is actually going out MPLS-A. We can also see that it's 0:1. That's the path ID, and I just happen to know that because I created this. And so the path ID is 0:1. And then Baby Bell's path ID is 0:11. Now, how did that actually happen? What actually happens is when we're over on Belgium, now Belgium, of course, is this branch site right here. So Belgium actually will go ahead and you can do a show master traffic class summary. Now, one of the really interesting things about IWAN is you can see that my exit point is MPLS-A. Now, if you do a show run include MPLS-A, you'll notice that we don't actually have it in our configs. It's not in here at all, in fact. Really what ends up happening is the concept of IWAN, the Intelligent Wide Area Networking, is you want to have transport independence. So a lot of people actually want to go ahead and say, you know what, I like this IWAN, I'm going to start using the internet. So instead of having 2 MPLSs, I'm going to take this one port, I'm going to move it over to the internet. Instead of going to all of the branch devices and actually saying, okay, you are now INET A, and potentially fat fingering that, really trying to make it all very templatable. So basically what you do is it is up here, so it is actually in Bojangles and Baby Bell that you say that this is MPLS. So let's go ahead and go over to Bojangles and do a show run interface tunnel 10. And what you'll see is that I am saying on Bojangles, which is this one right here, I'm actually saying that this is domain IWAN, it's path MPLS-A, and the path ID is 1. So that's actually how I know the path ID is 1. And so if we do a show run section domain, this is really all we have. As you can see, this is a domain lookup thing. This is the domain path that's on the tunnel, and these are aliases that I have. And so this is what you configure. Now, if you actually look at this and then you go over to, oh, I don't know, Chick-fil-A, if you go to Baby Bell, or if you go to Chick-fil-A, this is going to be identical. This is a copy and paste. You take it in and you say go to the master controller, because Bojangles and Baby Bell, which are on the MPLS, and Chick-fil-A, which is on the INET domain path, all are going to be borders reporting back to the domain master controller. And so you do a copy and paste. So basically what happens is that Bojangles as well as Baby Bell will actually send a welcome down here over the tunnel 10 on the DMVPN. And so if you actually go here to Belgium, you can do a show master status. And you can see that we have learned, actually, this is the MPLS. And I actually have, just to let you know, 2 data centers. But for what I'm doing here, I'm only doing traffic between Site 1 and Data Center 1. So the 0 actually is the POP ID, or the point of presence that you actually have in front of your data center. And so 0 is when you actually have the domain master controller, wherever the domain master controller is, that is your hub transit site. And that will have a point of presence or a POP number of 0. So this is 0, and this is Bojangles because that's the path 1. And this is 0 because it is in the same hub site as the domain master controller, and 11 because of the fact that the, over on Baby Bell, instead of actually having path ID 1, I have path ID 11. And then from that perspective, this is actually a box that is over, that is an MPLS head end that is actually over in a different data center. So if we actually do a show run interface tunnel 10, I actually have 2 NHS in my DMVPN tunnel environment that are going to data center 1, which is 10.101, and I have another NHS which is 10.100.10.6, which is over in data center 2. So that's that. Now let's go ahead and do a show master traffic class DSCP EF, and then we're going to do detail. Now, as I mentioned, the live action is actually telling us that the traffic is coming into Belgium and it's going out to the MPLS as the primary channel. So this is where the traffic is actually going right now, and it's actually going into path 0:1, which is Bojangles. So let's see what this says. This says that the present channel is MPLS, and it's going to 0:1, which is Bojangles. So that's a 2, and this is Baby Bell. So it's a 2 and a 7 as far as what I want to write in here. So, oh, I'm so sorry. Yes, so the channel is, so the primary channel is a 2, and the backup channel is a 7. And I said that we are going to 0:1, which is Bojangles, and the backup channel is going to 11. Now that's that. Let's go ahead and go over to, now I really like this, by the way. Now you can see, like I said, that I was actually doing practice before I did this and making sure that I had a list of what I wanted to show you. This was the delay that was happening before. This is the policy decision point, which will actually let you know why am I where I am. And so you will see this when we actually cause delay, that there'll actually be delay in this environment right here. Now, if we go back up to the other side, and instead of doing a summary, we do a DSCP EF detail. Now, detail, actually, what detail will give you is, detail will also give you this part down here. If you don't do detail, then it only gives you this part up here. So it's 46, and it's going out Bojangles, and 44, which is going out Baby Bell. So that's 46 and 44. So that's 46 and 44. and the path ID is 1, and the backup is 11. Now what actually ends up happening is it's saying that this is actually picking it randomly. If we had more traffic there, it wouldn't necessarily be random, but since this is the first traffic flow out on that MPLS, then I don't really have anything to balance out there. So this is all of this, so let's go ahead and go back over here. Now what we're going to go ahead and do is we're going to cause impairment. I am going to go right here, and I am going to cause delay. Now let's take all of this because we already have that from here. And this is the before. And so what I'm expecting is from an afterwards perspective, because I'm going to cause delay on the physical transport underneath tunnel 10 over which both paths go, I am expecting for us to realize that there is impairment over both paths and get off of MPLS, go over to INET. Now, then I'll also expect that one of these will actually become the backup channel. This will also happen in the other direction. So let's go ahead and see again how our traffic is doing. So let's go over here. And we actually have, this is our latency, this is our average latency. So I'm going to go ahead and I'm going to come in here. This is a WAN bridge. You can actually get this for free out on the internet. So we're going to say 5 meg, and we're going to do 200 delay and no packet loss, and Control Alt. And what we're going to see is we're going to see this dip down, it already did, and then dip back up, okay? And then we're going to have reordered packets. Why are we going to have reordered packets? Because we caused this horrible delay on the MPLS. So we caused this delay that is crossing a threshold crossing alert. It is crossing because for EF, we put it in policy voice, and the threshold for that is 150. It's not supposed to cross 150. It did cross 150, it's at 200, so get off of MPLS and go over to INET. So why the reordered packets? The reordered packets are there because of the fact that it takes me a little bit. As you can see, 19 frames. I'm sending 100 frames per second. So it took me less than a second. Actually, it took me less than half a second. Actually, it took me less than a third of a second to realize that there was a delay that was crossed the threshold and we needed to get off of MPLS. So let's go ahead and go back over here and see what ended up happening. So from this perspective, if we do a detail, we'll see that we're on 45. So now it's DSCP EF. We were on the MPLS, but because of delay, and see here's the delay, 199, right? We were on MPLS A, we were using path 1, which is Bojangles, and then we went over to INET and we're using 02, which is actually Chick-fil-A, which is the INET path, and we're using channel 45 now. And so let's go ahead, and so 45 is our primary channel now, and it's going to INET, and our backup channel is 46, and it is choosing Bojangles. So 45 and 46. So let's go ahead and go over here. And so this is 45, and the path ID is 0:2, which actually means Chick-fil-A. And then the backup channel is 46. So basically what happened is the primary channel became the backup channel. And so if we look over here, and that was path ID 01. And if we go ahead and come up here to Belgium, and we do the same thing, we'll see again that we were going out MPLS A, and now we're going out INET, and now we're 9 and 2. So let's go ahead and update that. So this is path ID 9. It's going out INET, and then 2. And again, Daisy, sorry about that. And again, the primary channel from before became the backup channel. So, and then we hauled butt and we went over to the internet. Now again, why did we go over to the internet? So it says delay. It says it was 166 in this direction. But here we go. So this is Belgium. So we would like to be on the MPLS path, but we see here that delay, which is this one right here, TCA delay, is actually a failed and failed. So for the threshold that is voice, uh, these uh, these paths, it would not be intelligent to send the traffic over. So we're going over what was the fallback. And again, we can do the same thing over here. If we do a detail and go to the bottom, and we can see that we were wanting to use the MPLS, but the MPLS is like, you know what, there is a problem, so it is failed, but the fallback is active and it is good, so use the internet. Okay, and let's go ahead and go back over to the live action and say, okay, so which way is it going now? So what is this flow doing now? And what I'm going to tell you is it's going to go ahead and it's going to go out of Denmark and over to Chick-fil-A and out. So now it is on the INET path. And that's it. A little bit of lab rat fun, networking with fish, looking under the hood together with IWAN, and just having a blast. Have a great one. I'm out.